Hi, this is Roman, and today we're going to be talking about Unit 8, Conditional Probability, Day 9, Combining Events, Part 1, with a focus question of how can we use tables to represent sample spaces and to calculate probabilities. So I'm going to be focusing on slide 13 and 14 and showing a few samples of solutions here and how we can get to them. So let's begin here. So for our first question, we have two standard number cubes were rolled 20 times, and the results have been entered in the tables below. So we have on our left-hand side here, we have, as I use a laser pointer here, the first and the second cube, and then we have the number of rolls listed horizontally. So for example, on the first roll, the first cube was a 6 and the second cube was a 2. Now let's take a look at our first question here. What percentage of the rolls are doubles? So for this, let's take a look at this sample space and let's circle every double we see. So it looks like we have a double on our 5th row, a double on our 7th row, a double on our 11th row, 13th row, and 19th row. Let's make sure I didn't miss any here. Oh, I missed one on the 6th row. All right, so that's a total of 6 doubles that were rolled out of 20 possible outcomes, or the 20 times that they were rolled. So that would be 6 over 20 as our answer to A. Now I'm going to go to my Desmo Scientific Calculator. And as I click, if I choose to write 6 over 20, because I see the question asks me for a percentage, I'll see 0.3, and it's my responsibility to know that 0.3 stands for 30%. Okay, let's move on to B. So for B, we are asked, what percent of the rolls are doubles and have a 6 on the first cube? So for this one, I'm going to take a look at all the doubles that I've circled here in blue, and I'm going to analyze which one of them happen to have a 6 on the first cube. So let's see, let's put an X on everything that doesn't have a 6. The 5th roll does not have a 6 on that first cube. The 6th roll does not have a 6 on that first cube. The 7th roll does not have a 6 on that first cube. And the 13th roll does not have a 6 on that first cube. So that leaves us with the 11th and 19th roll as doubles that also have that 6 on the first cube. So doubles and have a 6 on the first cube are the 11th and 19th roll, which are 2 out of 20, which simplifies to 1 out of 10. And if we can't see the percentage right away, again, we could type in 1 over 10 into our Desmos calculator, and we'll see that's 0.1 or 10%. And there's a quick review here, right? If we see something like 0.1, we are moving our decimal point 2 places to the right to create the equivalent percentage. Let's move on to C at this point. So what percent of the rolls are doubles or have a 6 on the first cube? So first off, we figured out what percent were doubles, right? So we had 6 out of 20 for that. Our OR here means we are going to do a sum. ORs mean a sum, and if we think about it in terms of winning, doubles, we win, or if we have a 6 on the first cube, we also win. So I'm going to remark up this diagram here, and I'm going to use blue again. So again, the first thing I'm doing is just highlighting all the doubles. So again, I got my 6 out of 20 there. So now what I want to do is I want to represent that second part of that OR statement with having a 6 on the first cube. So let's do that in green. So I see the first option has a 6 on that first cube, the 8th row, the 15th row, and the 20th row. Now, if I count 1, 2, 3, 4, it's an additional 4 out of 20. Notice how I didn't count the 11th or the 19th row, because that would be counting them twice. That would be counting them as doubles and on the first cube. If we use the addition rule, we would have to subtract. So let's show the final answer here. This is 10 out of 20 as our final answer, which is, if we count here again, if we have 10 out of 20 possible outcomes, well, that's half, so that's 50%. And if we are choosing to use something like the addition rule, right, well, that would be 6 out of 20 for doubles plus 6 out of 20 for options that have a 6 on the first cube. And then we take away the 2 out of 20 in red here for what I have in terms of the repeating, because it repeated. We're counting them twice here, right? We're counting them as doubles and 6 on the first cube, so we want to take those away. And if we do that, we'll get 12 out of 20 minus 2 over 20. And again, we get to 10 out of 20. That's using the addition rule. For our last question, we are asked what percentage of the rows do not have a 6 on the first cube. So let's make this easy for us here. So let's change this question up to 100% minus the probability of having a 6 on the first cube. So probability of having a 6 on the first cube, right? Well, we already have a few here, right? The first roll has a 6. 1, 5, and 7 don't. The 8th roll has a 6. That's 2 total. 3 for the 11th, as we're counting. 4 for the 15th roll. And then 5 for the 19th roll and 20 for the 6th time that occurs. So another way to write this would be, we have 20 over 20, or the total amount of outcomes, minus the 6 times that it appears on the first cube. And that gives us a total of 14 out of 20 as our solution. So once again, here is just a sample of how to solve questions with our focus question in mind. In this case, let's take a look back at slide 9. How can we use tables to represent sample spaces? So this was an example of how to use those tables to represent sample spaces. And we did review how to convert percentages in this case, also the addition rule, the difference between an or and an and probability, as well as a subtraction of 1 minus the probability of having something to represent the probability of not happening for an event. All right, I hope we found this video very useful.